Oh yeah, welcome back to Galantidos Academy. So in our last video, we treated questions on chemical bonding, and most especially we treated question on ionic bonding and covalent bonding, right? And I promised you all that we will be diving in like to the further part of chemical bonding, right? So in today's video, we'll be talking about two other types of interatomic bonds, right? One of them is called metallic bonding, and the other is called what? Coordinate bonding. All right, so these are basically the other type of bonding or bonds, right, that are found between atoms, right? So if you are new here, just refer back to my video on ionic bonding and covalent bonding, right? You should note that, okay, I'll talk about it when teaching coordinate bonding. Okay, that said, first, what do you understand by metallic bonding? When I say metallic bonding, what do I really mean? Right? Okay, it's nothing hard. It's really nothing hard. When I say metallic bonding, I'm actually talking about a kind of bonds that occurs in metal from the word metallic. So this kind of bond occurs in metals and their alloys. It is characterized by sharing of electrons among a closely packed array of metallic atoms. Do you understand? Among a closely packed of metallic what? Atom. So whenever you come across any question on metallic bonding, you should note they are talking about the kind of bond found in what? In metals. Do you get that? And the kind of bond that metal have gives it its special properties. All these characteristics you all know about, right? That is malleability, conductivity, and the rest. Now let me show you. Let me give you a practical example. Let's assume these are metallic block, something like this, right? So we have boom. These are atoms, right? These are atoms. These are atoms. All these stuff are atoms. All right. So all these guys are atoms. So we have the the nucleus, the nucleus in all of them. The nucleus is in everything, right? While in all these guys, there are actually electrons. I'm representing only the valence electron now. Do you get that? So they are all electrons in the last shell. They are all electrons in the last shell. Can you get it? All right. But now the electrons here are kind of different. Do you get that? They are kind of different in that they are highly mobile, right? That's why in metallic atom they when describing their property, they do say that metals have what? Delocalized what? Electron. Delocalized electron. So now, what do they mean by delocalized electron? When I say delocalized electron, what exactly comes to your mind? Now, delocalized is actually an English word, and it means when something is what? Free to move. When something is what? Free to move. So being free. So metals have what? Free electron. That is, they can jump from their own valence electron, their own valence shell, right, to a new shell, right? They are capable of that kind of movement. I get the point now. Now let's imagine the scenario. If you and your friend share the same bank account, that is, you open joint account. This is common between husbands and wife, right? So these both of them share an account, right, with money in it. I get it. They share an account with money in it, right? So, and this the money in here, the money in this box belongs to both party A and party B. You get the point now. It belongs to both A and B, right? If A wants to probably buy something or do something that probably want to buy a Lamborghini or Rolls Royce, you be like, guy, I have say no be the money we to hold the share and I want to buy this car. You get that? Like whatever party A is doing connected to money, you want to be interested in that matter. You get it? You want to be interested, you'll be like, oh, I hope it's not my own money you're using for this. Do you get that? So in this kind of thing, right, there's a kind of connection, right? There's a kind of connection between A and B. Do you get that? So they will hardly fight each other, right? Though fight might arise, but they will settle fast because they know that anything can happen to their money. You get it? They will settle fast and stuff like that. So that kind of thing happens in. It also happens here too, right? Also happen in this guy, right? In this So now this electron here can move here. This can move here, right? This can move to this part, right? So they are always moving. They are on the move always. They are always what? Moving. They are always moving. So that's the fun part of it. It simply means that they are sharing something valuable to both of them. They share something valuable, right? So this singular movement or this unique property keeps it together, keeps the metal together. Do you understand that? And it accounts for several properties that we know of. Example are the conductivity, right? Conductivity. What exactly is conductivity? Conductivity is the ability of an atom or a compound to conduct electricity or to pass electricity through it, right? Whenever a metal or an atom or a compound allows current to pass through it, right, it has what it can conduct, right? The conductivity level is higher. Do you understand that, right? So now this metal can conduct electricity because a particular electron in this point, right, can receive what charge and move to this point, right? Remember they are what delocalized. They are what delocalized. So it's actually possible for them to transfer from one part of the atom to another, right? That's exactly what this metallic bonding is all about. I get it. It's actually nothing really hard, right? So when I'm talking about metallic bonding, I'm talking about the kind of bonding that holds atoms of metal together. And also note that metallic bonding can also be found what in alloys. It can also be found what in alloys. Now, what are some of the properties of metals, right, that is related to their bonding, right? What I've talked about conductivity, right? Another is malleability. What exactly is malleability? Can you try? Okay, now when they talk about malleability, they're talking about an ability, the ability of a metal to be beaten into shape. I get it, or hammered into shape. Hammered into what? Into shape. Another property of metal is actually ductility. That is from the word ductility, right? So ductility. When I say ductility, what exactly do I mean by ductility? Can you try? Okay, it's actually the ability of metal to be drawn into shape. Drawn into shape. The ability of a metal to be drawn into shape. And the most malleable metal is what? Can you try? Alright, gold is the most malleable, followed by what? Copper. Please take note of that. So that's for metallic bonding now. Nothing much to say about that, right? So now let's move to the second one, which is what? Coordinate bonding. Coordinate. Right. So when I say coordinate bonding, what do I really mean by coordinate bonding? Okay, coordinate bonding originated from covalent bonding, right? Covalent bonding. And for it to originate from covalent bonding, right? So it's simply meaning that they will share similar characteristics. I get it. And now, who can try? What are the kind of the unique property of covalent or unique characteristics of covalent bonding? Who can try? Yeah, correct. Sharing of electrons. That is what? Sharing of electrons. I get it. So now this sharing of electrons is between what? Two of the metal, two of the atom, sharing of electron between atoms. Note that the electrons were contributed by the two atoms present. I get it. The electrons in covalent were contributed by two of the electrons present. Did you get the point now? Okay, now let me give you a very good example so you'll be able to relate well. Now let's talk about nitrogen molecule. Now, what's the atomic number of nitrogen molecule? Can you try? 7. So it looks like this. You remember in bonding, it's not all the electrons present or all the electrons that a particular atom has that is involved in bonding, right? It's only the valence ones, right? I've explained to you what valence electron is all about, so refer back to the previous video. Okay, now for this, now it has what? 5 valence electron. That's 5 valence electron, right? Something like this. And for the second one, it will be like this. Do you get the point now? Okay, now, so remember octet and duplet rule. That is, all atom wants to reach that level, right? They want to attain an octet configuration or a duplet configuration. So there are two things, there are two ways that this stuff can proceed. It can either lose the 5 electron, right? Lose 5 electron, or gain how many electrons? This is 5 already. Gain 3 electrons. Which do you think will be easier? Can you try? Definitely gaining 3 electrons. Do you get that? It will be very hard for it to what? Lose 5 electrons. So it has to gain 3 electrons, right? Oh, sorry, I didn't complete this. 1, 2. You get the point now. Alright, so it has to what? Gain 3 electrons. Now, how can it gain that 3 electron? Okay? It can actually say, okay, hello guy, I need 3 electrons from you. And if this transfer 3 electrons, it will be deficient of how many electrons? 6. Right? Yeah, 6 electrons, which is kind of huge. And it can't sacrifice itself that much. Right? So they will now say, okay, you know what? Let's share the electrons. I get it. Just like joint accounts now, right? You put in money, I put in money, both of us have it, right? If I want to do something important, I will borrow from you. Do you get the point? So they actually what? Share the electron between them. The electrons are being shared. You get the point? Good. Now, what's unique here? That is the bond formed here, bond formed in covalent were contributed by the two atoms involved, right? Contributed by 2 atoms involved, right? Okay, now But you see this coordinate. Do you get that? In this coordinate, it's only one of the atom that contributes everything. In coordinate, only one of the atom contributes to the bond. Do not forget this point. That's what distinguishes coordinate bonding from covalent bonding. All right, let me clear this space. Now, when I'm talking about coordinate now, still on coordinate. When I'm talking about coordinate, right? Some exam or some invigilator or some examiner would like to say dative, right? Or coordinate covalent bond. They are all still the same thing. Do not be confused. So one thing I want you to take home today is that coordinate bonding, right, has to do with sharing of electron. But it has to do with sharing of electron. But the bond formed, I get it. The electrons used to form the bond were contributed by only one of the atoms, right? Only one of the atoms contribute to the bond. So just take note of this. Okay, now this coordinate bonding is very, very broad, right? And it's kind of formed the basics of Lewis base and acid. I'm sure you have heard of Lewis base or Lewis acid and base, right? Lewis is a person, so he looked at acid and base in a very different dimension from Arrhenius or Bronsted-Lowry, right? These are several guys, right? So according to Lewis, he said that an acid is actually an electron pair acceptor, right? So an acid is an electron pair acceptor. An acid is an electron pair acceptor. So the opposite will be for this, right? The opposite will be for that part. So don't forget that. So it's an electron pair acceptor. Why a base is what? An electron pair donor. This is a donor. An acceptor. Now I'm going to use an example. So you'll be able to capture all this information I'm trying to squeeze together. Okay. I'll use the example that every one of you here know about, right? Which is NH4 plus. That is derived from NH4Cl. So NH4 plus. Okay. And we all know of NH3, right? And H plus. It was the union between ammonia, and hydrogen ion that gave birth to this. The union between ammonia and hydrogen plus that gave birth to what? Ammonium ion. Now we want to find out which of them is the donor and which of them is the acceptor. Right? Okay, let's move on. Let me talk about this first. So this is how it goes. So we have N 1 2 3 1 2. A bond is formed between them. Right? I talk about how this structure came about in my previous video. So something like this. There is a lone pair. There are two electrons that are separate. There is a lone pair of electrons here. Right? Why for this? Let's look at the structure of H plus. How does it even look like? First, how is an ion formed? An ion is formed when there is a loss or gain of electron. An ion is formed when there is a loss or gain of electron. Now H plus, which is hydrogen ion, how did it arrive at H plus? How did it acquire the plus electron, the plus sign? Okay, definitely by losing what? Electron. By losing what? Electron. First, how many electrons does hydrogen have? Hydrogen has only one electron. So that means as we speak currently, it has an empty valence shell. It has an empty valence shell. So the only thing it can do, right? The only thing it can do is what? Accepting electrons. The only thing it can do is what? Accepting electron. Okay, why for this structure? You see this guy here? I get it. Let's find out why it's even entered coordinate bonding and not covalent bonding. Let's confirm if it's actually octet. This is 2, 4, 6, 8. This guy is complete, right? Nitrogen is complete. He's satisfied with his life. He's satisfied with his result. So if it enters into only ordinary covalent bonding, right, the one that both of them contribute to the bond, I get it. The electron, the valence electron, will be more than 8, which disprove our law. How are you getting this? You are getting this gist now. So that's why it has to undergo what? If it's a must, it must form a bond. It has to be what? Coordinate bond. Coordinate bonding. Is this getting? I getting now? Okay. Let me represent it well. Okay. So you will understand it. So now this side goes, and we have our hydrogen here, plus. I get it. So it forms the bond. This nitrogen or these 2 electrons, this lone pair here, I get it, forms the bond. So whenever you see a coordinate compound, it's always represented with an arrow. These other examples of coordinate compound includes your hydrozonium ion, right, and so on and so forth, right. This example is not about it's not for practice. You get, it's about helping you understand the concept. Do you get that? So this is all for that. Let's have a quick revision on what we treated so far, then we come to the end. Okay, in metallic it occurs in what? Metallic bonding occurs in where? In metals, right? It occurs in metals, and it accounts for most of the properties. That accounts for most of the properties. What of coordinate? What of coordinate? Can you try? There is sharing of electron, right? But the shared electron is contributed by only one atom. That is, the bond is formed by only one of the atom. Do you understand that? Remember that a bond is formed by 2 electrons, right? So this bond, or the electron needed in forming the bond, was donated by only one of the atom. Good. So in coordinate bonding also, there is what is known as donor, or one of the atom acts as donor and the other one acts as what? Acceptor. One of the atoms acts as donor while the other acts as what? Acceptor. Do you get that? So this actually forms the basis of Lewis acid and base. And I also said that an example of Lewis acid, or an example of coordinate bonding, or where you can find coordinate bonding, includes ammonium ion, hydrozonium ion, etc. Alright, thank you so much for being part of this video. Thank you so much for watching this video and clicking on this video. I really appreciate it. And if you have any topic in mind that you want us to explain to you in a better way, in using different formats, please ensure that you comment, right? You comment it, right? If you want us to bring any videos to you, just comment it in the comment section. And if you like something, or like something unique, or if there's anything unique about us, please also comment, right? And if you want us to improve on certain things, please also comment. Your comment means a lot to us, right? It helps us to forge ahead, right? Please and please, thank you so much. And share, click the subscribe button. Do not forget that. Thank you for watching. God bless you all. Bye.